Jeffrey, are you there?
Can you hear me?
Yeah, I can hear you. So it's 1 minute after half. Probably we should start.
All right. Are you running or?
Let me do the introduction. Thanks everyone to participating, and welcome to Rift at IETF111. Glad to see you here, and we'll spend a few minutes providing you update on what's going on, and then move to the presentation. IETF not well. Make sure you're familiar with the terms and the IETF processes. If you aren't, please make yourself familiar. Everything you share becomes property at IETF, and you need to know that before participating. So the agenda is to quick update on our side. Then we'll have a base spec update and RIFT-VPN presented by Jordan, and some new work about using Rift and rings from Sandy. So from overall progress and working group status, thanks Alvaro for great work on reviewing and working with authors on better text. Version 13 has been posted and is going to be presented today. Applicability statement is still in working group last call, and progress is good. All the comments are mostly progress, and Jeffrey is going to shepherd it. Young model is almost ready, and thanks to Michal Vashka for Young review. So we are going to progress it. There's some other active work such as key registry and work on EVPN, as well as some ongoing work on segment routing and multicast. And if there are no questions, we are ready to move to the next presenter, Jordan. Okay, let's see. Jordan, we are ready to go if you are. Cannot hear you.
It seems to be coming in and out. It seems to have been trouble.
Refreshing the browser. Ask for a minute.
Yeah,
Jordan, I still cannot hear you. So let's give it another minute, and if Jordan cannot fix his mic issues, I assume Tony could go instead.
Also seems to be having trouble. He's in and out. Oh, I see he's still in.
He's working on it. Give him a sec.
guys hear me okay?
Try to talk loudly. Jordan?
Wonders of modern technology. Maybe I start, and if he fixes his mic, Jordan can take over.
Sure. Please go ahead.
Yeah, I have no idea what the slides are. I reviewed them and I completely forgot them. Cool. Yeah, so in short, we got tons of work done. Jordan, you there?
Yep. How about now?
Okay, so why don't you take it?
Okay. Yeah. Sorry about that. No idea what's going on. 1 second. Let me get situated. Okay. All right. So thanks, guys. Thanks for being patient. So here to present version 13. Historically speaking, the protocol works. It's been implemented to spec, but the document itself still needed some work. Between Alvaro and other working group members, I think we've made some pretty major progress on helping this move forward. So I'll run through this. So first, I've been added as a contributor. So I've fought some of these dragons in the past, but I had the benefit of essentially having unlimited resources. But as we know, that's not the case for most operators. So, since around version 11, when I initially read it, I've kind of felt that Rift's approach to these problems have had a ton of merit, and knew I wanted to contribute ever since. So since then, much of the feedback I've seen is pertaining to readability. That's where a lot of my time has been spent. Beyond that, as Rift has been going through ED review, Alvaro's been giving us some great feedback in that area, and others. But that's where the bulk of the collective work went. Let's see. So we've added a new Reader's Digest section. So basically helps the reader figure out what they want to learn about Rifts. Got some shiny new SVGs. I think we're one of the first drafts to use them, let alone quite so extensively. And as such, we hit a couple of bumps in the road along the way, but we can go over that momentarily. And then some other restructuring items. So with the help of some of the folks from the applicability draft, moved a couple sections over there as they were just a bit better suited. Even some small stuff like reducing the table of contents step was just small but welcome, made things seem a bit less daunting. Next slide, please. So it's a new protocol. Obviously, the draft is going to be pretty big. But, and as with anything new, you got to start from scratch a little bit. So it kind of comes with a steeper learning curve compared to something smaller. So again, we got some great comments that kind of suggested the draft might be a little difficult to consume. So a bit more detail, we streamlined the abstract and introduction sections to better prepare the reader for what's to come. But again, most importantly is that Reader's Digest section. So helps them really understand what matters, whether they're going to implement or operate Rifts. Audience doesn't really matter. It should fit for just about anyone. But what you're left with is, kind of a better understanding of everything. Abstract introduction tell you what Rift's about, main benefits. And then the Reader's Digest section, the reader now has the ability to kind of break things into more reasonable chunks, or if they want to target a specific subject. They know which sections provide the level of detail that they want. Maybe they're an operator, just want to know how it works at a high level. Maybe they're doing something complex, implementing negative disaggregation. It's basically choose your own adventure. But yeah, we felt it gives the reader a much better experience and kind of command of the content. But other than that, throughout the draft, there's been some additional references to keep some things, just more cohesive, right? So if there's a concept that benefits from a reference to the thrift model, or just to maybe a different figure, kind of helps the reader maintain the same train of thought, so they don't have to context switch quite as much. Okay, next slide. So syntax, not inconsistency tax, right? So kind of keeping with that readability trend, we made some terminology and language changes, consistency changes across the board, just avoid any unnecessary confusion. And I think it helps readers not second guess themselves if something varies even slightly, right? Whether it's an implied concept or just a difference in capitalization. But, and the same thing was said for shifting between kind of the first and third person point of view. We moved everything to third person now, so there's more of a kind of consistent flow and experience for the reader. And next slide. Okay, so the most visibly noticeable change is the addition of SVGs. We ran into some nifty challenges that we didn't think of initially, but a little bit of learn as you go. But we actually broke the draft submission tool a little bit. So SVGs are obviously much larger than ASCII, so there's a 3 meg limit on that, and so we had to get it manually posted the night of submission cutoff. We did reach out to the tools folks. I don't think we've heard back yet. So kind of as a side note, if the chairs have any suggestions, that'd be appreciated. Anyway, there's some other considerations, but I digress. Most everything now has an SVG equivalent image. We think it helps the reader tremendously in certain areas, primarily multiplane fabrics and negative disaggregation. So, multiplane fabrics are one of those things that you kind of get it or you kind of don't. There's not a lot of in between, so they can be quite challenging to really understand. So, a few of the images really help you kind of bridge that gap and help them understand how things fit into Rift, which kind of perfectly segues into the negative disaggregation components, right? As we know, it's required for multiplane fabrics, and for the readers that want to know those concepts, the SVGs are super helpful. But yeah, if you look at the figure to the right, that's what we used to do some of the multiplane fabric, and making that work in ASCII it's not pretty. Believe me, I tried, probably spent more time on it than I should have, but anyway, and then the FSMs are a lot easier to parse and digest since we don't have to kind of pick apart the ASCII diagrams. And kind of a final note, the text versions of the draft will still fall back to ASCII. So, we're not going to leave anyone high and dry. Next slide, please. So some other points that came up in review was, or what were we actually standardizing? So to be clear, it's the thrift models, and leaves things a bit less open to interpretation. Other text in a sense is supporting detail to describe how things work. So one of the things too is Alvaro mentioned is we're still working on getting a stable thrift reference. I think Tony reached out to those guys. We're just giving them a little bit more time, but we're owning it and pursuing it. But beyond that, just kind of continuing to respond to Alvaro and going through the review process. So I think I'm a couple minutes under if there are any questions.
On the comment from my side, I'm really happy with the changes in version 13. The document has become so much better. Great job. Just kudos to you.
Yeah, thanks. Definitely was all the authors.
Yeah, by you I meant the authors, not just Jordan.
No, yeah.
Accidentally removed you from the queue. Go ahead, Tony.
Yes, on the thrift stuff, I poked the folks. I'll be poking them steadily until I get, some kind of commitment from them for the steady reference. Otherwise, yeah, tons of work, couple of months. Thanks, Alvaro, for actually drilling down very, very deeply in a lot of details. And most work has been done by, pretty much Jordan, Pascal, and me. I think also Bruno did some stuff.
Okay, if no more questions, we could move to the second presentation. Oh, sorry, Alvaro, you said I'm not, you mean you're not done in general, not right now, right?
Right. All I meant is that I'm not done with the review, right? So.
Great, thank you.
All right, let's make sure we can still hear me. It looks like we can. Okay.
Yes, we can.
Okay. Shifting gears a bit. So this time I'm sharing our new iteration of Rift Auto-EVPN. So we submitted the first version last meeting at 110, and it was a little bit of a teaser, kind of just describing what the solution was. With the submission deadline and everything, we didn't really get a chance to fill in quite as much as we wanted, but that's what we did this time by adding a lot more detail into things, how things actually work. Next slide, please. So very quick recap. So what's this Auto-EVPN thing again? So the short of it is Rift ZTP functionality will build the underlay, and that actually provides us with a lot of really good topology information that we can use to derive things necessary for BGP and EVPN overlay. So we get that ZTP functionality extended into the overlay. We receive lots of EVPN purely for the sake of stretching layer 2. So we're striving to kind of resurrect a little bit of layer 2's original sense of simplicity, where you could just plug some stuff in. Next slide, please. Okay, so what's actually new in version 1? So much like the main spec, we're considering the thrift model to be normative. We've got some variable derivation procedures. So previously, again, we just had simpler verbiage, but now we point to actual algorithms. There's some scale considerations we'll get into in a sec. And then something I find particularly interesting, Auto-EVPN analytics. And same as mentioned above, where that's also going to be a normative model. It's a little bit noteworthy. It's also the first major use of risk key value store. Okay, next slide. Okay, a little bit more about the model and kind of what it's describing. So the model itself contains all the necessary variables, data types and so forth that we use to build the BGP sessions and the MAC VRFs themselves. So just, brief examples, right? Loopback IPs, cluster IDs, route targets, VLANs, VNIs, so forth. There is reliance on a couple of modifications of the line tie schemas from the main spec. Those were mentioned in the original version, but they essentially define interoperability between nodes that can run Auto-EVPN and nodes that can't. Next slide. So just a brief example, like I mentioned, this is just one of the example algorithms for how route reflectors are elected, but similar algorithms are present for the other variables. Next slide, please. Okay, a couple scale considerations. We kind of had our default set to do 1 fabric, 1 EVI with 7 VLANs. This version of the draft sets the max to 3 fabrics, with each having 3 EVIs and 15 VLANs apiece there. It's not that it can't scale beyond this, it can, but additional mechanisms would have to be defined that describe how to keep VLANs from colliding. As one example, right? Whether a VLAN can stretch across fabrics or not. Next slide. Okay, so the analytics piece. So this version introduces what we're calling Auto-EVPN analytics. So for those of us who have built EVPN, it can be a bit challenging, or at least tedious, to troubleshoot and verify, partially because it's data plane driven, partially because it's distributed across various nodes, all sorts of reasons. So basically, we provide the TOF nodes with the ability to see the general status for the entire Auto-EVPN fabric. We do this by using Rift key value store, the Rift key value store, to advertise KV ties from Auto-EVPN leaf nodes that it contains information both about the node itself and the MAC VRFs. And there's, excuse me, well, we've also included the thrift model that kind of defines that. Next slide. So digging a bit deeper, we reserve two key types from the KV registry. One identifies kind of global attributes and another the MAC VRF. So the global key type will define the Auto-EVPN node's role itself. So Auto-EVPN leaf, for example, as well as the number of operational peers and the number of total configured peers. So from just the TOF, you get the ability to see every leaf's BGP state. And the other key type identifies MAC VRF details. So the number of operational CE interfaces, as well as the total, and kind of help you understand where your services related state, what it looks like downstream of a leaf. The number of operational IRB interfaces as well, same thing. Totals included. Get a little bit more understanding, reachability and routing. And then, given that EVPN is data plane driven, a view of both Type 2 MAC and Type 2 MAC IP routes give you a bit more insight into that piece of it. Did someone just advertise 500,000 MACs into the fabric, etc. Just helps you look out for outliers. So there's some other identification information as well. How many VLANs are configured, the name of the MAC VRF, and a description for where maybe that name doesn't describe, or at least describe well what the service really is. I don't know, being able to see those factors in a kind of quick condensed view, all from the TOF. You don't have to log into multiple devices, was something we thought operators would find beneficial. And next slide. Okay, so what's next? Co-authorship and comments are still welcome. The next revision will have a lot more detail around Type 5 routes. And last but certainly not least is we're asking for adoption both for this draft and the key value registry. And then next slide, and if there are any questions.
Sergey, go ahead. Sergey?
Cannot hear you, Sergey.
Maybe Tony first.
Sure. Well, I hope the LSR is not sabotaging our mics or something. Just joking. For the Auto-EVPN, two observations. The maximum numbers, we can flip back to this view graph, wherever it was, the maximum numbers you can derive. You want to flip back so people have context. So we had this, how many fabrics it supports and how many EVIs it supports and so on. No, we don't flip back the preso.
To where, which slide specifically?
The one that was talking about maximum numbers, 6, okay. All right, so basically, what does current maximum mean? It's actually the current, yes, it's a little bit of a mix between maximum and defaults. So the defaults currently are, you derive it on a fabric, of course. So the fabric is not really a default, it's just the number 1 fabric is the default. And I think the default currently stands at 3 EVIs and 7 VLANs. And what do the maximum mean? The maximum does not mean that that's the biggest config that you can generate automatically, But what we did when we provide the algorithm, we tested that up to 3 fabrics generating on each fabric 3 EVIs, and in each EVI 15 VLANs, all the derived values are collision free. So in the sense, the maximum here means you can implement it and use those algorithms up to these values and everything will be collision free. And from there on, we don't consider, it's important or, relevant, practically speaking, to check further. So that's first observation. And then on the analytics, when you go and look at the key value store analytics, I don't know which view graph that was, 8?
8.
Can we flip forward?
Absolutely.
One more?
Maybe one more.
Those chairs are slow today. All right. So if you look at the, the global analytics stuff, or even the per meg VRF, where you have a lot of stuff, you ask yourself, well, but lots of stuff isn't advertised. Like, for example, loopback of the node, which is also auto-derived. But the trick is that the TOF has all the information already about the nodes participating to be able to derive all those values itself. So there is no point of sticking them in key value. So for example, the unique loopback of the node, the V6 loopback, doesn't have to be advertised because it's algorithmically derived, and the algorithm is based on fabric ID and system ID and so on, and the TOF already has it for the participating node. So if you want to see the status of the fabric and you want to see all the loopbacks, you don't have to flood that. You can just run the algorithm's proxy for all the involved nodes and you will get the information. That's why we actually do not flood a lot in the key value store. Most of the stuff can be derived at any point in the fabric. Well, actually, you would look at the TOF because it has all the information. So those are the two things from my side. So maybe Sergey fix the mic.
Hear me now?
Yes.
Yeah.
Hello?
Yep.
Yes, we can hear you.
Please go ahead.
Oh, okay. So I have a simple question. So I haven't read the draft just yet. My first part of the question is, am I correctly assuming that this is always creates essentially a single EVPN service per fabric and a single broadcast domain? And the second part of this question is whether you specify a specific type of EVPN service, so whether it's VLAN based or VLAN bundle or VLAN aware bundle, or it can be any type of EVPN service.
Jordan, you want to take that? Otherwise, I'll answer. Okay, I'll answer. So the first question, yeah, his mic died again. I don't know what kind of technology is running, but seems to be pay as you go. All right, so the first question was whether you have a single broadcast domain. No, you don't. The Auto-EVPN derives as many EVIs as you want. So currently the default in the draft is 3. But we tested, I don't remember, up to 7 EVIs on a fabric, which are collision free. And within each of these EVIs, it derives 7 VLANs. And some of them can be stretched across fabrics and some not. Now, what kind of service you're running on this thing is up to you, in a sense. We do not specify how you do trunking because the trunking is not clear, right? So an implementation might, for example, choose to listen on interfaces and see that there is no L3 running on it, and then basically chooses as a trunk interface. and then you define on it what kind of service you want. What you get from Auto-EVPN is basically an EVI and the VLANs derive, and then how you bundle them, what you do with them is not specified by Auto-EVPN. It's interesting discussion whether we should be going into that. The problem is that those things are very hardware specific. What kind of service models are supported on different hardware platforms? So I don't think we will find a solution here. Maybe we should derive a certain amount of EVIs, providing a certain service type and define that. But Auto-EVPN doesn't have to derive anything. But maybe we can say that, for example, EVI2 is whatever VLAN aware, and that's how you're supposed to run it on all the leaves. But it's a good observation. Let's engage on the mailing list about this stuff.
Yeah, and it's an important question, Tony, because different service interfaces don't necessarily interwork very well. And probably VLAN base would be the most basic one. You define 7 VLANs, you define 7 VNIs associated with it, and you map one-to-one. But it's a good discussion.
Right now. Yes, because that's what pretty much all the hardware supports, right? But if you want a VLAN bundle service, I mean, we can write the draft in a way saying, like, for example, derive the third EVI as a VLAN bundle. Let's engage on the list. It's a good observation. But yes, we implicitly today, frankly, implementation-wise, pretty much everything supports VLAN aware, and that's what we're doing.
Okay, I have two questions here. The first question is, you mentioned there is a RIFT for underlay and Auto-EVPN for overlay part. Now, the Auto-EVPN part, how much does it involve the RIFT itself? If we go talk about this concept in the best working group, how will people there understand this Auto-EVPN concept?
Up to me to answer. So it was already presented last IETF in the best working group, and the concepts are pretty clear to people. Is that stuff RIFT specific? No and yes. Why no? Because this is basically derived a certain deployment model, which is called the EBR, RR IBGP model, which is very common. So everybody understands this kind of model. It's very, popular and implemented by all the vendors. So in a sense, it's just, instead of manually doing, lots and lots of configuration, this thing just automatically pops out configuration for you. Yes, because you need to place the correct nodes in the correct place in the network. And only RIFT has enough topology understanding to do this. So as a simple example, the route reflectors are placed at the top of the fabric normally. And RIFT has all the information to understand where is the top of the fabric and put these things on top of the fabric. Now, could other protocols place it somewhere else? Yes, they could. You could possibly build ISIS to support that, but then the leaves are at the bottom of the fabric. ISIS has no concept of a bottom. So how will you figure out who the leaves are? Right? It's almost impossible to tell. ISIS has no sense of direction. And the other part is analytics, but there is nothing particular, to RIFT. You could also stick the TLDs into something like ISIS. So no, there is nothing that is RIFT specific when it comes to the EVPN concept. Anyone in BAS understands it that doesn't have to understand anything about RIFT to understand the concept, what we're doing. But yes, because other protocols do not have enough topology understanding to be able to derive the correct configuration on the correct nodes, unless they are, of course, hacked to put a lot of concept in, at which point in time they start to look like RIFT by some other name, conceptually speaking, despite different encodings and mechanisms. So that's the answer.
Oh, thank you. So my second question is I think you mentioned that there are certain features we couldn't do because we don't know what the intention is. So you couldn't derive things like trunking mode or whatever. So is it? I assume it will be possible to have mixed auto EVPN and non-auto EVPN together in the same deployment. Is that true?
Yeah, absolutely. I mean, it's just BGP. You just set up more session and you put more EVIs in. You know, it's really implementation specific. You know, what we focus on the problem of giving someone a pile of switches who has absolutely no idea how EVPN works and IGP works, and they just plug in cables, enable that, and they magically have an L2 network going. You know, with predefined VLANs and broadcast domain and so on, which is an interesting offering in enterprise space. The other solution, of course, having a controller doing all of the stuff, which is more of a day one config, right? This is more like a day zero config. Controller being, of course, more flexible and allowing, you know, asymmetrical deployments. This stuff is, in a sense, completely symmetrical, right? It's a one size fits all. You get what you get here. If you don't like it, well, you know, bad luck. If you put in too many knobs, pretty soon it's not, you know, ZTP. It's basically a very complicated command line. So it depends what you're interested in, right? But we don't preclude on a node having a mix implementing a node implementing something where beside the Auto-EVPN, the normal VPN is also being run. I mean, we don't also preclude with Rift someone running at the same time ISIs on the fabric or BGP or whatever. All these things can run the ship in the night.
Thanks. And should we move on?
Yeah, I think so. Sandy, you're right.
Hello?
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 We can hear you. And
Oh,
lights are
yes.
up.
Great. Okay. Hi. This presentation is for supporting leaves without northbound neighbors connecting to a fat tree network using Rift. I'm Sandy Zhang from ZTE, and we have co-author Yuehua and Benchong. Next, please.
Before you
This is the
continue,
new. Okay.
slides are not completely visible in default mode. You need to go to toggle zoom and probably toggle them to see them.
And I can move I can roll it, and I can see the full screen, and it can be moved or make the screen smaller, and I can see it. But
Yeah, I just made it.
But
Yeah.
I'm okay. Yeah.
Resize the browser and keep it in a mode where you have the participant list on the left and the presentation on the right, and you will see the full slide, at least I think.
Yes. Now it's okay for me. Yeah. Okay. And let me continue. And this is the new metro network. And the spine leaf topology can be deployed to replace the traditional topology. Rift can be used as a dynamic routing protocol to build the network. The access network may connect to the core network through some leaf nodes by ring or chain topology. For example, the IP RAN network. Next, please. Okay, this figure is an abstract of the new metro network, especially the leaf part. We know in typical Rift protocol, every leaf node has a northbound connection with spine node. In case a leaf node lost all the northbound connection, it can still access the network by east-west neighbor. But in this deployment, some leaf nodes never have northbound connection, even if their east-west neighbors have northbound connection also. Looks like they can access the network through the east-west connection, but according to the typical Rift protocol flooding and SPF algorithm, the leaves cannot advertise their prefix not tied to the network, and the leaves cannot receive the prefix source tie for the default route too. For example, in this figure, there are 6 leaf nodes in the figure, but only L1, L2, and L3 have northbound connection with spine nodes. L4 and L6 can access the network through L1 and L3, but L5 cannot access the network because it and its neighbors haven't a northbound connection. Next, please. In order to solve the problem, the key is let the leaf node without northbound connection receive the prefix source tie for the default route from the east-west neighbors, and send the prefix not tie to reach to the leaf node which has the northbound connection. This is the change for flooding. The leaf node without northbound neighbors must transfer the prefix source tie received from an east-west neighbor to the other east-west neighbor, which also has no northbound connection. And the leaf node without northbound neighbors must transfer the prefix not tie received from an east-west neighbor, which has no northbound connection to the other east-west neighbor. Other flooding function and SPF algorithm are not changed. In this figure, L4 and L6 must transfer the prefix source tie received from L1 and L3 to L5 with increased metric, and L4 and L6 must transfer the prefix north tie received from L5 to L1 and L3 with increased metric. So L5 receives the prefix source tie and find the way to access the network through L4 and L6. L1 and L3 receive the prefix not tie and pushes the tie to spine node. The nodes in other side of the network can send flow to L5, and L5 can send flow to the other nodes in the network. A new link capability is defined and named leaf transport. It can be set in line and node tie. This capability won't affect the line FSM. Next, please. That's all for the problem and the solution. We'd like to know, does this problem need to be solved? And if there is any other solution for it, any comments welcomed. We have received some comments from Tony, and we discussed in the mailing list. If you have interesting in it, you can look at the mailing list. And for now, we are looking for more comments. Thanks.
Okay, since the chairs are asleep, I jumped the mic, Tony P. Juniper. So can we flip back to the second view graph, please? Okay, so I think I gave a comment on the list that if you don't do anything, Rift will work fine per the right part, right? The leaf where it basically builds a hierarchy. And there was a very good observation from Sandy that when you break a link and you have to renegotiate the hierarchy, then of course new adjacency need to be formed. So if you lose a link between the gateway and an A, then this A will fall under the bottom A hierarchy-wise, which will work, but it will of course interrupt the traffic flow. So that's a good observation itself. And then to the solution that Sandy is suggesting, next view graph, please. And next one. Okay, so there is two problems here, right? So the first observation is that there is no north ties being sent across a horizontal link below TOF level. So we're not talking TOF. Let's take the TOFs out of the equation. So when you have leaves, horizontal links on leaves talking to each other, you will only send the south ties to each other, basically to attract traffic from one to the other, right? Because right now, leaf to leaf, you don't propagate the southbound farther. So yes, we could extend the protocol, and like I told you, we basically start to build RIP, right? The LO6 sends to LO5, and the LO5 sends to LO4, but it sends also to LO3, and then you find the shorter metric, and it will lead to all the counting to infinity if you have complex brackages like an RIP, but it can be done, and it will not re-establish the adjacency. But you have a second problem. The LO1 and LO3 will not advertise D4 routes because there are the leaves and they have no southbound neighbors. So they do not generate a D4 route. So the LO6 will get the LO3 prefix, but it will not get the default necessary to forward into the rest of the fabric. So we would somehow in those extensions also change those rules, which is doable. So overall, yeah, we will have to reinvent RIP on this kind of topology to solve the problems that level negotiation, when the different level is negotiated, the link is being torn down. We could also look at that in more detail, but I do not think that it will be very fruitful because it's very inherent in when you change the level, you have to advertise a lot of stuff. So I think the adjacency, keeping the adjacency up while you're changing the level will be much more complex than reinventing the RIP. So those are my two observations, right? The first one, that Rift works already, while the brackages will, depending what the breakage is, but the breakage may bring down your adjacency and bring it up again. And the second one is that we would have to change the default advertisement rules. And yes, we only do the prefix south ties, which is enough to run the RIP on this kind of ring. I'm done. So best take it to the list, I guess.
Thanks, Tony. Very clear clarification. Because I'm ignored many details in the flooding rules existed in Rift protocol, but so Tony P has explained it very, very clear in this situation. So I think so may I get the conclusion that it's interesting and it need to be solved. Much appreciate for your help. Thanks.
Sandy, do you feel you've gathered enough information to progress here? You require further discussion? You would like interim focused on the solution? Because it's definitely needed. If you look at modern 5G rings deployments, that's what you see. And valid question from Tony, how many people would want to work with that? Is it something you see as a problem, or are there more people interested in this work?
Yes, we when we talking this topic with when we talk Rift with our customer, they think that we should do something to research to for the for the deployment. So they think that if we it's great if we cannot change the topology existed. So we think that and there is many IPRN in the network now. So we think that if we can use Rift directly, and we find this. Yeah.
Here's another observation, Sandy, because of course I dealt with this kind of discussion as well. It is very easy to redistribute Rift back and forth into other protocol, just like another protocol. So, and I had it also in different contexts with BGP. You could just take on L01 and L03 and just redistribute the Rift differ route into an RIP and just run an RIP L01, L04, L05, L06, L03. Also very easily done. That also solves the problem if L04, L05 which are not even Rift capable.
Yes, but Rift can RIP can only be used in the ring, right? So I don't think operator wanted to deploy two dynamic routing protocols in the network.
I don't think anyone would want to deploy RIP today in general. There's no operational experiences whatsoever.
You can deploy whatever you want, right? It doesn't really matter. Any dynamic protocol will do. So, okay, I mean, if you really want just a single protocol and on breakages, you insist, you don't want to change topology and you insist that on breakages, you cannot have a link, traffic interruption, then yes, we would have to add something like that if all those things are non-negotiable. Okay.
Okay.
Tony, you
There's
mentioned
a question to you from Sergey. I'm not sure whether his mic is working, but he is asking the customer whether the primary reason for customer to ask for it is because of its auto configuration capabilities.
So Sandy can answer for her, discussions. I can answer for my discussion. So, right. So my discussion went along the lines that the metros are changing to claw for a lot of reasons, and 5G are slower to go, and the rings actually have quite a lot of undesirable properties. For example, the longer you make it, the more you delay becomes non-uniform and longer, right? So the discussion goes often towards like, why don't you build a claw? It's a much more desirable property beside redundancy, also uniformity, right? But if they want, the ring, then I found that it's not a big concern if I tell them, look, Rift works, it just builds a hierarchy that you don't see. And the discussion topic that when a link breaks, it may need to renegotiation of hierarchy and you have a traffic interruption, frankly, that was first time I saw the argument being made by Sandy. So that's from my side.
Yes, and the operators think that if the topology cannot be changed and the new technology like Rift can be used, they think it's great. But if they want to use Rift and they must change the topology, they may think that it's too changes for the topology, so they may not want to update it. So, but I think it still needs more discussion because the network changes may bring many big changes for the topology. So anything can happen, right?
But in general, I would say that problem statement is valid and correct. I've seen, any tier one today, you look in US, is trying to build leaf-spine network, disaggregating. And a lot of stuff is in rings, and you need to cut rings to build physically spine topology. So there's definitely transition period where the bottom part is a ring, because this is how we've been building network in optical layer for the last 20, 30 years, right?
It's great if
And
you
to
have
Sergey
any.
comment, a lot of the stuff is running spanning tree today.
Yeah. If there is any successful deployment, please send the materials to me, and much appreciated for it.
But the question here to people in working group, is there enough critical mass to organize interim and actually look in depth into the problem?
Right, because if there's enough interest, I mean, yes, the solution can be built. You know, the question is, do enough people care to actually go and do the work? We can add the capability and we can change the behavior on the capability. That's not even a big deal. But like I said, it will have RIP properties. So if you lose a link, you know, and all these people that are attracted to decide where the link is lost, they will need the propagation of the routes, and you'll have traffic interruption anyway, even if you don't lose, even if you don't break adjacency. No magic, right?
So apparently, we have people from ZTE interested in working on this. I guess they can at least they can continue their exploration and then figure make their solution more robust and address the concerns that so far Tony has raised, and see if we can reach a level where the working group can consider it should be adopted or not. But as initially, at least I think you're always welcome to continue the work as individual document, right? That's how I see it.
So Sandy, let's see whether there's enough critical mass. So anyway, please continue working on this. Again, from my perspective, I see it's a valid problem statement. It does exist, right? So if we can gather critical mass, would be better. Obviously, if working group supports you, you work together. If not, you could continue, and eventually, when Drive becomes more mature, ask for adoption.
Other questions, comments? No. My computer shows 6:30 now.
Yeah, we're out of time. Sandy, thank you for presenting. And so please follow up on the send an email, and we'll try to gather working group consensus, see what's going on here. And respectively, please continue working on this.
Okay, thank you. Thank you very much.
Thanks, everyone.
Thanks, everyone. And
Thank you.
hope to see most of you in person just, a few months from now.
Bye-bye.
Okay.
Bye, everyone.
Bye.
Thanks.
Thanks. Bye.